Hello, I'm here to talk about density, and we're in the chemistry labs. We're in the scale room. You see the chemistry labs? That's what they look like when they're empty. But we're talking about density, which is mass over volume. That's why we're in the scale room. So, we take our scale, and it's nice, it's digital. We hit 0. We give it a moment, and then we put our flask on. I'll normally put a piece of paper on because we're working with a solid sample, and then we get our measurement and we just write down that number, 22.823. All right, and then we're going to fill it up with our unknown. We're going to fill it up with water, and the idea is when it is filled all the way to the top with water, since we know the density of water, we can take the mass of the water divided by density, and we know the volume. If this was all the way filled up, takes out human error. Now, if we fill it only to this point here, it's a lot easier. We just have to get the volume to that point, which would be 25.00, because these are made very precisely. But I'm judging my meniscus. See how good I am. All right. Maybe if I can pause. We have all the data for both parts of the lab. So I filmed this lab and something happened. So we're doing it again. And so all the data over here first about the liquid. It's an unknown A. I'm going to tell you a secret. It's aluminum. Don't tell your teacher. It's aluminum. And that's for the solid, sorry. The liquid is also unknown A. And the liquid is isopropyl alcohol, also known as isopropanol or 2-propanol. You actually need to know that because you're going to decide how I did. You're going to figure out which way was more precise and which way was more accurate. So you're going to have to Google the actual density of isopropyl alcohol, or IPA, right? And of aluminum, and see how I did. So I did each one 2 different methods. So with the liquid, the flask was the same flask. It was a volumetric flask. And this method over here, so the mass empty was the same. This method, all I did was I filled it to the meniscus. And I estimated that it was perfectly at the meniscus with my very keen eyes, because I have the hat on. I have my Knopf on, which makes my eyesight even better. So we just say, okay, the volume is 25.00 milliliters, because that is what the volumetric flask means. It can be read to 4 sig figs. Subtract out the flask. You'll know the mass of the unknown. This method requires extra steps, but it does tend to be, for students, much better. See how your teacher did, since she had to do it twice. So the idea here, if we find the mass of the water by subtraction and divide by the density of water, which we know from the big book of everything. It's a really big book. It's a big book of chemistry and physics. And I looked up the density of water. And somebody figured it out to that many sig figs. So using this density, we can figure out the volume of the flask. Meaning when it's filled with any liquid, it's going to be that same volume. So that will be the volume also for our unknown. Now, you just have to always subtract out the flask to get the mass of your unknown, divided by the volume of the flask. This lab's also about sig figs. Remember, when you subtract, it's place value. So just be careful to always keep the place value there. So it's not the number of sig figs, it's the place value. Now with the solid, I did it 2 ways. Once was just simple displacement using graduated cylinder. So I just estimated with my keen eyesight, due to the Knopf, 39.0 milliliters with water, found the mass. And then I added my unknown, aluminum, until I had displaced it and it wasn't quite to the 50. So I guessed. So it's just below the 50 of the meniscus, the bottom meniscus, so it's 49.8. That's the idea of sig figs, is that last digit is the guess. And so simple subtraction, you're going to show your steps, respecting sig figs. Cannot have as many sig figs, so not as precise. Is it more accurate? It's much more simple. Thing is most students, they're so far off. This method is a lot more steps, but it tends to be much better. So you're going to do the math. So here is how we can find the volume of our flask. This time it was a 50 milliliter Erlenmeyer flask. So here's my Erlenmeyer flask. This was a volumetric flask. They have a different shape. And this is a graduated cylinder. So a graduated cylinder can read all sorts of volumes. Somebody knows how to read it. A volumetric flask only reads one volume, unless we fill it all the way up. In an Erlenmeyer flask, it's really imprecise. But what we did with the cork on, always with the cork on, you fill it all the way with water, get the mass by subtraction, which will show the step, labeling all your pieces, divided by the density, same density as before, you'll know the volume of the flask. And then you just walk through the steps to find the mass of the metal and the volume of the metal. Because by subtraction, we can figure out how much water is added to the metal. Subtract that out from the total volume, we'll know the volume of the metal. You have to walk through the math, and you're going to label your steps carefully. You can do abbreviations, M for mass, FL for flask, H2O for water. All right, many blessings, and let's hope this time I videotaped correctly. Have a wonderful day. Don't know if it's snowing. The gnomes say, ta-ta for now. Maybe, maybe not.